Today we're going to look at simultaneous equations again. That is when we've got two equations with two unknowns and we have to combine them to find both of the unknowns. You could have three equations and three unknowns. There's lots of possibilities. We're going to focus on two equations and two unknowns. But today we're going to look at equations with different coefficients. Now I just need to talk about what that means because so far we've looked at them where they're the same coefficient. So coefficient is the number in front of the x or the y basically. So for question 2, the coefficient of x is 3 and the coefficient of y is 1. There's a secret 1 there. On this next one, the coefficient of the x is 1 and the coefficient of y is 1. So if we look at this, we see for this question, both of these coefficients are 1. For this question 2, both of these coefficients are 1. And for question 3, both of these coefficients are 1. So that's kind of making life a little bit easier. We'll see in a minute why life gets a little bit tougher if they're not the same coefficient. And actually, we can see a whole methodology involves like eliminating some of the unknowns, and so if they're not the same coefficient, it's a lot harder to eliminate them. All right, I'd like you to pause the video now and have a go at these 4 questions. Okay, so question 1, the method I taught was we're trying to find when the y values are the same, so we can simply set the y's equal to one another. We can then rearrange it. I can add x to both sides, and I can minus 2 from both sides, and I'm going to get x equals 2. I can substitute that back in. I could put it back into either one of them. 2 times 2 is 4, plus 2 is 6. I can check it. 8 minus 2 is 6 as well. I know I'm correct. So I did that quite quickly. Number 2. So here you can make y the subject and then do the same as we did for question 1. But I think today I'm going to stick with elimination. So to eliminate the y's from this equation, we can add these two sides together and these two sides together. And what that means is that we get 4x, and then the minus y and the y cancel, and I'm left with 18. Okay, and then I'm going to carry on down here. Then x is going to be 18 divided by 4, which is 4.5. I get a decimal solution. If I then want to work out what y is, I probably would just put it back into this one. I'm going to get that y is 12 minus 4.5, and that's going to give me 7.5. I can just double check. If I substitute it back in, I'm going to get 23.5. Oh no, wait. Sorry. 3 times 4.5 is 13.5. Minus 7.5 is going to give me 6. So again, I know that one's correct. This time with decimal answers, a lot harder to guess, but elimination works really nicely. Number 3, okay, which of the numbers are the same? Well, no, I can't just always go with the middle numbers. Here the x's have the same coefficient and they're both positive. We said that if they're opposite signs, we can add them. If they're the same sign, either both pluses or both minuses, then we can minus them. So what I can do is I can do 1x minus x, which disappears. 2y minus y gives me 3y. You need to be careful with that. And then 3 minus 6 gives me minus 3. So then I'm going to get that y is minus 1. And I can substitute that back in. X minus 1 is 6. So I can see that x is going to equal 5. Again, if I check, I do 5. Minus 2 is 3. I know I am correct. Brilliant. One more to look at. So in this 4th example, I've not given you an equation. I've asked you to solve it, but I've not just given you simultaneous equations. So the mean of 2 numbers is 11. The larger one is 1 more than twice the small number. Find both numbers. So let's call the smaller number x. And the larger number y. Can do that. So then the mean of the 2 numbers is 11. If I want to find the mean of 2 numbers, then I add them together and I divide by how many there are, which is 2. and that is going to equal 11. That's my first simultaneous equation that I can create. And then the larger number is 1 more than twice the small number. So that means I've got twice the small number, and then the larger number is 1 more than it. So I then need to add 1 to that, and I've created my simultaneous equations. This is a bit messy at the moment. What I would do is I would multiply through by 2 for this one. So I've got x plus y equals, not 11, 22 by multiplying through by 2. And there's a few things I could do now on this one. I think what I'm going to do is, you know what, I'm going to use our old method of substitution. Basically, I'm going to now rearrange this one to make it y equals 22 minus x, and then I'm going to set these equal to one another. 2x plus 1 equals 22 minus x. I'm not far off. I can see that it's going to be quite nice. I'm going to get 3x plus 1 equals 22. 3x equals 21. X will equal 7. And then I can put that back in. I put it back into this one. Y is going to equal 15. And if I just check it, if I add these two together, I get 22. Divided by 2, I get 11. Again, I know I'm correct. So that's just a quick recap of simultaneous equations, and well done if you're happy with that. Number 4, we haven't really spent much time on this sort of thing. We will come back to it, but it's a little challenge for you. I hope you're happy with 1, 2, and 3 at the very least. Okay, let's do this. Let's look at some simultaneous equations with different coefficients. Here we go, okay? Here's an example of simultaneous equations with different coefficients. I've got a coefficient of 1 in front of the C here, but 2 here. Here I've got 3, and here I've got 1. I want you to just pause and think, how can we solve this now? Okay, there's a few ways we could do it. The way I'm going to teach you is we're going to stick with elimination, and I'm going to again make a case for using scales just to get the idea across. So I can set up my equations back as scales. I've got 1 cherry and 3 peaches, and that weighs 750 grams. And I've got 2 cherries and 1 peach, and that weighs 500 grams. Okay, what can I do to try and solve this? Well, I really want them to be the same number of cherries or peaches on both sets of scales, because then I'm in business. I can do what I did before. But I can basically do that. I can imagine I've got my peaches. Okay, I've got my 3 peaches here. And I got my cherry. What if I then did another 3 peaches and a cherry? What would that weigh? Well, I've got one lot that weighs 750 grams, but this other lot is identical, is also going to weigh 750 grams. And I can say that this is 1,500 grams. What I've done basically is multiplied the equation by 2. Okay, I've taken this first equation and it's become 2c plus 6p equals 1,500. And I'm going to keep the other one the same. 2c plus p equals 500. And now, just with this one little step, we can create an equation that we can deal with, because we learned how to deal with this. What can we do now? Well, I've got my same setup on the right. Okay, and I've got my 500. So what I can do now is I can basically do what I did before. I can take a peach and 2 cherries away, but that's going to mean I have to take 500 grams away from this side here. I've got 1,000 grams. Okay, so this is equivalent to me subtracting the equations, just like we did before. Subtract, I'm going to get that 5p is 1,000. Okay, I'm just showing it visually and I'm showing it algebraically, and hopefully you can see it's consistent, it makes sense. So yeah, I'm not going to use this last set of scales because basically I've done it visually here, I can now work out what P is. I can divide 3 by 5 and P is going to be 200. I can then substitute it back in. Okay, so I've got 2 cherries must equal 300 because I've got 200 here, so I minus that. And then C is going to be 150. And those are my answers. I can check them. I can put them back into the top one. I'm going to get 150 plus 600 is 750. I'm correct. I have solved a pair of simultaneous equations which have different coefficients, and the only extra step is that I need to multiply first. So in this case, I multiplied the top one, both sides by 2, which led to this equation here. Now I could have done it by multiplying this bottom one by 3. Okay, I don't think I'm going to do that right now, but you could have a go at it. But yeah, if I multiplied this bottom one by 3, I would make both of these 3p. And then I can again subtract them, but I'd solve it for C instead. Okay, hopefully you're happy with that. We're going to do 2 more examples. And let's have a go. Okay, we're going to just work algebraically now. All the scales have gone, but it's going to be the same sort of thing. Okay, I'd like you to make notes on this. Right, here I've got some simultaneous equations. The coefficients are different. So what can I do? Well, I can just make the x's the same by multiplying this bottom one by 2. It's absolutely fine to just multiply one of them by 2. Okay, because it's an equation. It's just like I'm doubling the scales. So what I'm going to get is that 2x plus 10y is equal to 62. What I think I'm then going to do is rewrite the equations. It's really important to just show our working carefully. And I'm going to actually write this bigger one on top. So I'm going to put the smaller one below. Okay, this is smaller because the 20 is smaller than 62 and the 3y is smaller than 10y. So it just means I avoid getting negatives when I then subtract them. I'm then going to subtract. And what happens? These cancel. I'm going to get 7y equals 42. And then on there, y is going to equal 6. I can substitute that back in. Okay, I've created 3 equations. I'll probably put it back into this one because x is sort of the simplest one in this case. Okay, so put it back in. I'm going to get that x plus 30 is equal to 31. So x is going to equal 1. Done. Okay, just to check, let's check it works. 2 times 1 is 2, plus 3 times 6, which is 18. 2 plus 18 is indeed 20. I know I'm correct. I've checked my solution basically in both equations, and I've solved simultaneous equations with different coefficients. Notice I could have done it for y, but I would have had to have got the y's the same. How could I have done that? I could have multiplied this one by 5 and this one by 3, and then that would have made them both 15y. Okay, but why do that when we can just do it for one equation? However, we're going to do one more example where we do have to do it for both equations. So if we look at this one here, well, you could argue that I can just multiply 2 by this top equation by 2.5, and then that 2.5 times 2 is equal to 5a. Okay, and that actually would work out okay. We'd get some decimals in there, but you normally see this question being solved by multiplying both equations to get the same number, but keeping all the numbers as whole numbers. Okay, so how can I do that? Well, I'm going to choose to make the b coefficients the same. So I'm going to multiply this equation by 2 and this second equation by 3. Now you might be thinking, why are you doing that? Well, it's a bit like when you're adding fractions, really. If I want to do a third plus a half, Then we multiply this one top and bottom by 2 over 6, and we multiply this one top and bottom by 3, which gives me 3 over 6, and then I get 5 over 6. I've basically found the lowest common multiple of 3 and 2, which is 6, and I thought, what do I need to do to both fractions to deal with that? It's exactly the same here. Find the lowest common multiple of your b's. In this case, that's 6 again. Okay, so then I'm going to multiply this one by 2 and this one by 3. Hope that makes sense. I'm then going to write down what I get. So I'm going to get 4a plus 6b equals 10. There's no reason why I have to multiply them both by the same thing, just in case you're wondering about that. Second one, I'm going to get 15a minus 6b equals minus 48. And now I'm in a great place. I've made the coefficients the same, these b's. I've got a plus and a minus, so what am I going to do? I'm going to add them together. So I'm going to get 19a. These are going to cancel when I add them. And then I'm going to do 10 plus minus 48, which is the same as 10 minus 48, which gives me minus 38. I'm going to divide through by 19. I'm not going to show all my steps for this. This is hopefully, your ability to solve equations is building, and you can see what I'm doing here. And I get a equal to minus 2. What I'm then going to do is I'm going to substitute it back in. I'm going to substitute it back into the first one. So it's going to become minus 4 plus 3b equals 5. I'm going to add 4 to both sides. 3b equals 9. And I'm going to get b equal to 3. Okay, so that is my answer. B equals 3, a equals minus 2. Just going to double check. I'm going to put it back into the second one. 5 times minus 2 is minus 10. If I then minus 2 times 3, I'm going to minus 6, and I do indeed get minus 16. And again, can be happy with this, so I can check my answer and see that it works. And that is it, okay? You just got to be careful, but as long as you take your equations and you do the same thing to both sides, you're okay. The idea is to do the same thing to both sides so that you get the same coefficient, so that we can solve it like we did before. Whew, great, what a topic. Have a go at some questions. Well done.